Have you ever found yourself pushing a table and it just doesn't move? You try again, it doesn't move. But you keep pushing because there's David Goggins standing behind you. And you push harder and harder. At one point, the table starts moving. Wow, you're strong. But why didn't it move earlier? Because the floor was rubbing against the table. This rubbing force, yes, rubbing force, is called friction. And that's what we're going to talk about today. If something wants to move one way, friction pulls it the other way, always opposite to the force applied. Imagine pushing a toy car on the floor. It moves, but after a while it slows down and stops. Why? Because there is frictional force acting on the car's wheels. If the floor is very smooth, like tiles, the car goes far. If the floor is rough, like carpet, the car stops quickly. This shows that there is a relationship between nature of surface and friction. We will talk about it later in this video. There are three levels of friction. Let's use the first example. Number one, static friction. When the table was not moving, this friction adjusts itself to stop the table from moving. This means force applied is equal to the friction. Number two, limiting friction. The biggest friction just before the table starts to move. This is the maximum force the surface can use to stop the movement. Here also, force applied is equal to the friction. Remember, here, frictional force is at its maximum. Number three, dynamic friction. When the table was moving, this friction is a little smaller. That's why once it starts moving, it feels easier to keep pulling. Here, the force applied is always greater than friction. Let's discuss some experiments to determine the factors that can influence friction. Number one, nature of surface. There are two blocks of same weight placed on the table, A and B, but a sandpaper is placed beneath B. When pulling both the blocks with the same force, we find that block B is harder to move. So what does this say? The rougher the surface, greater the friction. Number two, does surface area matter? Put the block on its big side and try pulling. Turn it on its small side and try pulling again. Which one do you think is harder to pull? Surprise! It's equally hard. Friction does not depend on how big the touching area is. Number three, does weight matter? You're gonna need blocks of same weight. Place one block and start pulling. It moves with little force. Now place two blocks and start pulling. You need a little bit more force. Place three blocks and start pulling. You will realize that you need even more force. This tells us that more weight you have, there's going to be more friction because the surfaces press harder against each other. Sometimes friction can be a pain in the bottom. If you find yourself in such a position, we know who you are. So we have to come up with ways to reduce friction. But friction is also not all bad. We need it. For example, walking. If there was no friction, you'd slip like on ice every time. If this video rubbed you the right way, hit that subscribe and like for more. You can try out the worksheet in the description box down below. I'll see you guys in the next video.